Hi. In this video, we're going to talk about solving quadratic equations in two methods, by factoring and then taking square roots. And so the first example that we're going to look at is x squared equals 3x plus 40. And so we want to solve this. Now notice I have an x squared term and an x term, and so I can't just simply take the square root of both sides. I can't just take the square roots. I'm going to have to end up factoring. And so in order to factor, when you think about what we're solving for a quadratic equation, we're solving for the x-intercepts, and the x-intercepts exist are the values of x where y is equal to 0. And so in order to do that, we want to set the equation equal to 0. And so I'm going to do that by moving my terms to one side, and then from here I can figure out the factors of negative 40 that add to a negative 3, which are a negative 8x and then a positive 5x, and negative 3 can be broken up into negative 8 and positive 5. And so then from here, figure out the factors that the greatest common factor between the first two terms, which is x, and then the factors that come out of the greatest common factor of the last two terms, which is 5. And then we see an x minus 5, or an x minus 8 rather, as a common factor that can be pulled out, leaving me with an x plus 5. And so a lot of us are going to skip this middle step, and that's perfectly fine. That goes straight to here. It's just to show you what you're actually doing when you're factoring. The zero product property tells us that if you have two numbers and their product is equal to 0, then one of them has to be 0. So if I take each of these factors and set them equal to 0, I can solve for the solutions. And it's important to note that these solutions are the x-intercepts. They can actually be rewritten as coordinates. Either way is fine. So the next method that we're going to look at is by taking the roots. And so how do I know that I'm taking the roots here? We could go ahead and try to factor it. And in many cases it will factor. However, since I see only one type of term, that quadratic term, and not the just x itself, but the x squared term, I'm going to get the x squared terms on a side by itself and isolate it algebraically, and then do as the name suggests, take the square root of both sides, which would give me, and we would simplify radicals, plus or minus 5 root 2. And so it's important to note, in a quadratic, we are looking at two roots, or two solutions. And in many cases, it's either two real solutions or one real double, and in some cases, not real at all, but still two solutions. And when we're looking at this example, when we take square roots, many of us focus on the positive solution. We don't think about the plus or minus, so that positive and negative. But it's important to note, when I take the square root of both sides, if I square that positive 5 root 2, I get a positive 50, and if I square negative 5 root 2, I also get a positive 50. And so that is where that plus or minus comes into play. The next example that we're going to look at is again taking roots, because I know this because it doesn't give me an x term, just an x squared. So then if I again isolate the x squared and then move forward in solving by taking square roots, well, notice here I get the square root of negative 100. Well, I can't take the the square root of a negative number. I can, however, it gets into imaginary numbers, and in this course we focus mainly on the real number system. We don't get into imaginary. And so when given a solution like this, we simply say a not real solution. All right, so the next and last example that we're going to look at, again here is, we notice we have an x and an x squared term, so we can't just take the square roots. We're going to have to end up factoring. And first off, I see a negative out in here. I just move it around so that my leading coefficient is positive, even if I have to factor out a negative, which in this case I didn't have to. This one I could just move them around. And so this, we could factor it in the traditional sense, thinking what factors add up to 0 and go about that way. But really, we should be able to look at this and see a greatest common factor of 5x. And so by factoring out of 5x, I'm left with x minus 3, which then zero product property allows me to find roots at 0 and positive 3. And so looking holistically, this would be what we call factoring out of GCF. 2 and 3 would be taking the roots or square roots. And then 1 is the very just traditional sense of factoring. So using these two methods, we can solve quadratics for the solutions, which are the x-intercepts in many cases. It would not be the x-intercepts in unreal or not real solutions. Thanks for watching.